And if I put 10 back into that, I get 1,000 minus 500, which is 500 then. Thank you. You're not sharing with me.
Yeah, for tomorrow.
Thank you. She's smart. She's smart. Yeah, I'm having ice cream for breakfast, Sean. That's right. Good ice cream. Right. Okay, so that's the first one done. So the first one is okay. Number 2 now is starting to get a bit harder, though. Yeah. So I'll just write down the answer for number 1. dH dt equals 100 minus 10t, which should equal 0. So that means t should equal 10, which means h will be equal to 500. Okay, number 2. A manufacturer wishes to make a can of cola. 1 centimeter squared of cola, the can I mean, will cost 0.03 pence. And 1 pence is 0.01 pounds. And the manufacturer wants the can to hold, so the can must hold the standard 330 centimeters cubed. Okay so far? So the manufacturer here is making a can, and they need the can to hold 330 milliliters basically, is the idea, which is a standard size for a can. How should they make this can? Because they could make the can tall and skinny or short and wide. So what is the best shape to make? Well, the best shape will be the one that costs the least, which will be somewhere in between these two extreme shapes. You understand the basic idea? So the first part, which I think you can all do now, I'll give you a moment, is what is the volume of the can?
Pi r
squared
h.
Pi or squared h. Now, they want you, it's kind of like the second half of this. I want you to put in the value of V to make what's called a constraint. So the V has to be 330. This is called a constraint. What does the word constraint mean? Does anybody know it? A limit. And why do you think I'm calling this a constraint or a limit? Yeah, true, it can't be more than 330 or less than 330, but how is it a constraint on the R and the H?
No? Why is a constant, so it has to be R or H that's changing.
Yeah, but why would it? Yes, and that's important. There's a limit on how it can change. Because if I make the H bigger, what must happen to the R must be smaller. And the opposite. So we call this a constraint because it limits our choice on R and H. We can't just choose any value of R and H. We're now constrained by this equation. Okay, is that okay so far? We can continue to the next part. So part B is find the height. Find the cost of the can. Part B. Okay. Well, the cost of the can will equal 0.03 multiplied by the area. Yeah, because for each 1 centimeter squared, that costs me 0.03 pence. Question, yeah? The surface area, yeah. Right, so what is the surface area? Well, you might have to think back to middle school, but for a cylinder you have 2 circles, so that's 2 pi r squared h, and then you have the round part. Of course not. Then you have the round part, which is pi r h. 2 pi r h. That's the formula. That is the formula. 2 pi r h. That's the area of the round part that goes around it. 2 pi r is the circumference. It's like a rectangle. What? You look confused.
Isn't it a pi r h?
No, because that would be wrong. Oh, that's awful. 2 pi or h. You're happy with that? Yeah. Now, the 2 is in common, so I can take that out. Wait, actually the pi is in common as well, so I can take that out too. 0.06 pi r squared plus RH. That is our equation for the cost. If I know the R and I know the H, I can know how much this can will cost to make. C. What is the cost of the can in terms of ore? Well, that just means here I should just rearrange this, so it's H equals 330 over pi r squared. Yeah. Then I can sub that in here, and I have the cost of the can using only the radius. So that would be 0.06 pi r squared plus 330 r over pi r squared. So that would become 0.06 pi r squared plus 330 pi r minus 1. Yeah, because it's 1 over r at the end. Huh? What's wrong? R over r squared. Oh, sorry, thank you. Slash brackets. There. That answers part C. Now the juicy part, part D. What is the R and the H if they want the minimum cost? So the minimum cost means that the derivative, which is 0.06 pi, 2r minus 330 over pi r minus 2, that should equal 0. That means 2r should equal 330 over pi r squared. So that means r cubed should equal 330 over 2 pi. So r is the cube root of that, which will be the cube root of 165 over pi. What is the cube root of 165 over pi, please? .745 centimeters then. And now on to finding the H. So we can go back to our formula that H equals 330 over pi r squared. 330 over pi r squared. So Monica, since you still have the value on the calculator, maybe you can just put it into this then. .49, that sounds about right. And then lastly, E, what we have to do is put these two values back into the formula for cost. And when you put them back into the formula for cost, just hit it on the calculator and I think you'll get 8 pence for this. Okay, got that? Continue? Yeah, okay. Now, what we've just worked out is the radius and the height. But when you're looking at this, you might think, hang on a second, in real life, a can of Coke is more than 7.5 centimeters high. Right? Like 7 centimeters is what? Like This much?
That's just.
Yeah. I think we have this right, don't we? Let's check. Yeah, we do. So what has gone wrong? Well, nothing has gone wrong. My model was a little bit too simple, because in real life, a real can of Coke... no, the method is right. In real life, what will happen is, on the top, it's actually more expensive because it's thicker on the top. So I actually said, to make this problem simpler, that the cost is always 0.03 pence per centimetre squared. But in real life, I think what will happen is the top will maybe be twice as expensive. It could be like 0.06 pence per centimetre squared. Because the top, as you know, you can't really push the top down, but you can push the sides in. So the top is thicker than the sides. I feel like it's at least, I'd say it's about twice as thick, the top and the bottom. Because the price of the top and the bottom is more expensive, what will happen is the equation will try to make the top smaller and make it longer. So it will end up being more of the usual shape. Yeah. So I just made it a little bit simple. You could actually do this again and just put in that information. The only thing that really changes is actually, let's see, if the top is twice as expensive as the bottom, let's see how that would change. The only difference would be in this formula. This here would have another 2 in, this here would have another 2 in it, because you have to use twice as much on the top as on the bottom. Yeah? That means this here would have a 2. That means this here would have a 2. That means this here would have a 2. That means this here would be a 4. That means this here will be a 4. That means this here will be a 4, which means this here will be a 2. So you can see the radius has now become smaller. Do you mind recalculating that here, please? Now 2.97 centimeters for the radius means it will be 5 centimeters wide. Monica, can you show me, well, 6 centimeters. Can you show me on your ruler how big is 6 centimeters? Would you say that's how wide a can is? Yeah, I'd say it's about that, isn't it? Okay, now let's calculate the height. So again, it would be 330 over pi 2.97 squared. So can we see what we get here for the height? 11.89 centimeters. So this is about 3 centimeters, and this is about 12 centimeters. Let's see, what's 12 centimeters? That's kind of looking a bit tall, but at least it's closer to the real value. Yeah. So I suppose I could add in an extra part F, about the cost if it doubles on the top and the bottom. What would be the size of the can? And it would be 6 centimeters wide and 12 centimeters tall. Yeah. I wonder actually, let me type in dimensions of a can of Coke, 330 milliliters. What is the size of a can of Coke? Stupid inches. I was going to say stupid American inches, but that would be wrong, especially on Thanksgiving. Couldn't be saying that. Okay. An American one is 4.83 inches high, but Americans have a bigger can of Coke. They use 355 milliliters. That is a well observed point. I don't think it's because they have an extra 30 milliliters of Coke. Okay. And then on the ruler again, it is diameter is 2.6 inches. What's that on your ruler in centimeters? Okay. So because my answer is close to the real value, it means my guess that the top is twice as expensive as the side is pretty close to the truth, because it made a can that is pretty similar to the real size can. Go maths. Right, next question now. Part 3.
Teacher,
Yeah.
when we are doing dy over dx,
Yeah.
how do we know if there is it is a maximum or the minimum?
Good. I never actually
Test it.
tested it. In the lesson we did on the second derivative, we could actually know if it's a max or a min.
But this one has only one value. So
Yeah.
it doesn't have a maximum value.
No. We could. No. That's a good point. Lee asked, how do we know that what we found is the minimum? Maybe what we actually found was the maximum, the most expensive can. Well, we can know it's a minimum if we simply check if the derivative here is negative. Because a negative means it's concave. Oh, whoops, I said that wrong. Negative means it's... Oh, sorry, I said that wrong. If the second derivative is positive, then it's convex. And that means it is definitely a minimum. Let's check the second derivative here. The derivative would be 2 plus 660 over pi or minus 3. Isn't that right? That becomes a 2 because it was 2r. And that comes down... Yeah, it is this. Yeah. Now, I don't even need to put in the value of r. I can know straight away that this is positive, because I know r is positive. It has to be positive, it's a radius. Positive plus a positive cubed. Positive. So, I definitely know that this is positive, which means I definitely know it's convex, which means I definitely know this is giving me the minimum solution and not the maximum solution. Good, okay. Happy with that?
No. Can we find the maximum point with that?
Thank you for your honesty. Go on. Can we find a maximum? Your original point was right. Because there's only one turning point, it means there isn't a maximum for this. The reason is the graph looks like this. If this is the cost, and this is the radius, I think it's doing something... Oh, it's doing something like this. Where this point here is the answer we got, 3 centimeters about. Yes? Chrissy, you're distracting me. Come on. This does not cross this axis. This shoots up to infinity, and this will go out to infinity as I move out to infinity here. Imagine what that can looks like. That can is infinitely wide, but has no height. And what would this can look like? Infinitely tall, but with no thickness. Pancake can and pipe can. Okay, let's go on to number 3 now. How many people could do number 3? Yeah, I don't think it's... Wait, just one person? 2, okay. I don't think number 3 is crazy difficult. Did you get... I wouldn't say it's crazy difficult, because this would be to exam standard of difficulty. Yeah, number 2 and number 4. Yeah, number 3 would actually be an easy one. Will I do number 3? How many people need to see number 3?
I haven't done it.
Who? Chu, have you done number 3? Sean?
No, I can't read that question.
You can't read the question.
Number 3.
Number 3 is what? Part C. That's the juicy part. Okay. I will help you. I'll let you try for a minute. What's happening here is a farmer wants to build a fence. The fence is 100 meters long. Oh, sorry, no, it's like this. He has a fence, and he knows that this, plus this, plus this, plus this, that's called the perimeter, and that's equal to 100 meters, okay? Part 1, oh, and we'll call this W, it doesn't matter, we'll call this L. I suppose really it should be the other way because of how I drew it. L and W. What is the perimeter? The perimeter will be 2L plus 2W. B. Oh, and so write down the constraint. The constraint is 100 must equal 2L plus 2W. So what must L plus W equal? 50. So increasing the L causes a decrease in the W. B, what's the area? The area is LW. And C, express the area as either L or W only. So that would be, let's say, L by 50 minus L. If I just take this, I can get W, it's 50 minus L. That's 50L minus L squared. What is the maximum area? The maximum area is when this is 0, which means L equals 25, which means W equals 25, which means the area is 625 meters squared. So, if he has 100 meters of fence, and he wants to have the most area, he should basically use a square. This will cover the most area of his land. Protect his precious, famous potato crop.
It has to be Irish.
What? That's so racist. You're such a racist now, but true. Okay. We've got this one done? Yep. Now I did number 4. So now number 5. How do we do with number 5? Yeah, we got it. Well done. It was a hard one. Who else got it? Was the difficulty understanding what the question wanted? Yes. I will start this, and hopefully once I start it you can continue. What I want, the idea is this. I can write the number 8 as the sum of two numbers. Let's just call it x and y. And I would like to find these two numbers. Now, of course, right now, we have many, many choices. We could say 4 and 4, 7 and 1, 7.5 and 0.5, many, many choices. So what is my constraint? My constraint is, I want you to pick two numbers such that when you multiply their product by their difference, it's a maximum. So if you multiply their product by their difference, this result here, let me call it OR, I want this to be a maximum. Let me just give you some random numbers as an example. Suppose I say 8 is 1 plus 7. Then the result here would be 7 times 6, which is 42. Now suppose I said 8 is 4 plus 4. Well, this is definitely not the maximum because the result here would be 16 by 0, which is 0. So there must be some pair of numbers that add to 8 but make this maximum in value. This is called the constraint equation. What should I do with this equation to help me get to the answer? Substitute. I could say y equals 8 minus x. I can put that in there and then it starts to begin. So I'll just give you a couple of minutes to try it now that you see it. You figured this out by yourself, Monica? The language didn't put you off then? No, okay, you knew what I meant by product and, yeah, okay. Dudes, I'm telling you, you should get some of this in Spar. It's delicious. Huh? Two things I recommend you buy: the Casio calculator and this.
Casio calculator is
This isn't.
But it has an
Oh, it doesn't. What type of equation do you get when this multiplies out? Yeah, it'll be a cubic.
minus 2x cubic.
Cubic equation. Good. Okay.
24.
I don't know. We let the other people get it too. I believe that you got it. So what do you do next, Sean? Very good. Nearly finished? Lee, are you finished?
Yeah, almost.
Finished? No, not yet. Got X and Y? What you get?
1.69 6.31.
Sounds believable? Let's have a look now. Okay. Let's see. So, if I sub the y in, I get the result is x by 8 minus x by x minus 8 plus x. So that will be 8x minus x squared by 2x minus 8. Yeah? So that will be something. 8x by 2x, 16x squared minus 64x minus 2x cubed plus 8x squared. So, if I calculate the derivative now, that's 32x minus 60...
That's 3x squared, 3x cubed.
Is it?
Wait.
No.
Oh no, sorry.
It's okay. 32x minus 64 minus 6x squared plus 16x equals 0. You can divide by 2.
I just put that in calculator.
Minus 6x squared plus 48x minus 64 equals 0.
Yeah.
Is that what you got? I'll divide by minus 2. 3x squared minus 24x plus 32 equals 0. Okay, this has two answers. The first answer is 1.69 and the second answer is 6.31. If you use 1.69 then y will be 6.31. If you use 6.31 then y will be 1.69. Either way you get the same result. You should say 8 is equal to 1.69 plus 6.31 or equivalently 6.31 plus 1.69. So if you say 8 is these two numbers added together, then their product multiplied by their difference will be maximum. Okay, yeah.
Teacher.
Yes.
And then can we just calculate this to get the answer directly like this? Or we have to work out the b plus...
Sorry, you'll have to show your workings.
The
Yes.
b plus...
Yes.
Oh, that's one right. Okay, I don't calculate.
Yeah, in the exam don't do that.
Yeah.
Well, this would be a pretty big section B question.
I have a question.
Yes.
On the exam, can you just put formula is pairwise the
Yeah, put in the numbers and then write the answer.
Yeah.
That's fine. That's
You don't have
fine.
to show the
No. That's overkill. What I should do, which I haven't done, is I should check that it's a maximum. So if it is a maximum, what should the second derivative be? Negative. Negative. So let me just check. Let's just have a look at the second derivative here. What do I get? 32. No, 32 minus 12x plus 16. That's going to be 48 minus 12x. If I use x as 1.69, it's still going to be positive. Which is a minimum. Yes? Did I do something wrong here?
No, we want maximum.
We want maximum, which means it should be negative. Yeah. Weird. But if I use the other one, x is 6 point... I think I know what's happening. Yeah, okay. Yeah, one of them's a max and one of them's a min. But you might be saying, what? Aren't they both the same answer? Well, not quite, because here, this is always a positive, but this will be positive or negative. So the reason the formula gave me two answers is because the negative one is a minimum value and the positive one's a maximum one. But we don't actually care, because really, if we're being super technical, I was only looking at the difference, not the sign. Anyways, which one is technically, mathematically, the maximum, the one that's negative,
X.
which has the bigger x in it. Yeah. Yeah, so I suppose technically this is the answer. Yeah. Yes?
I don't get how we got the equation xy times x minus 1.
From the question. I'll read the part that relates to that, okay? Where it said, the result of multiplying their product by their difference will be maximum.
No?
Yeah?
Oh, okay.
The product is x, y.
This is their product. Yeah? Yes? Okay, are we happy with that? Now, how did we get on with number 6? Yeah? Now, what I'll do is I'll set number 6 up for you so you can understand what's happening, and then maybe you can do it. So, in number 6, what's happening is you have a piece of paper. And then I take the piece of paper. Is it a square piece of paper? Yes. I don't know how big this is, so I'll just call this L and L. Or whatever it is. And then, what happens now is I cut 4 corners off. And I'll call each corner X by X. Then I'll fold this up. And I'll make a box. And we can see inside the box. Okay? And I want to make the box as big as possible. So my question is, how much of the X should I cut off compared to the total length? So, let's write down firstly what the formula for the volume is. So, that piece is how long?
L.
No.
L minus 12.
Good. This piece?
Equal.
The same. Yeah.
Okay.
And this piece?
X.
X. So the volume will be L squared minus 4LX, yeah, plus 4X squared X.
Yeah.
So the volume will be 4X cubed, sure I'm doing the question now, 4X cubed minus 4LX squared plus L squared X. Good. I want the volume to be a maximum.
Yeah. The second.
So the derivative is 12x squared minus 8l
X.
plus l squared x equals 0.
Yeah.
Okay, so now we need to solve this. How can we solve this? Well, we have two choices. We can complete the square or we can use the formula. So we can say x equals minus b plus or minus the square root of b squared minus 4ac
Yeah.
all over 2a. So x equals 8l plus or minus, what's that going to be? Root 16, is it?
13.
Yeah, 16l squared over 24. That means x equals 8l plus or minus 4l over 24. So that will be 12l over 24 or 4l over 24. So x will equal either a half of l or a sixth of l. So we either cut off a half or a sixth. Which is the maximum? Well, we can check with the second derivative.
Yeah.
We need the second derivative to be negative.
Yeah.
Okay, so what's the second derivative here? That will be 24x minus 8l. If I use l over 6 in here, then what will I get? I'll get minus 4l, a negative, which means it's a maximum. If I use l over 2, I'll get 24, so that's 12L minus 8L, that's 4L, that's a positive. So we reject this answer. So reject and accept. However, there is another perfectly good, and you know it, so don't say it. There is another perfectly good reason to reject the first answer. And what is that reason? It will cut out everything. If you cut a half from each side, then you have nothing left. If we go back to the picture, if I cut off half the length from each corner, then I've cut away everything. So x should be between 0 and L over 2, and not equal 0 or L over 2. Question? Different way? How?
I mean, I'm looking at what I did. I got the drawing of the box is made.
Yeah?
Somehow I landed with a ratio of the length to the x.
Yeah? At 6 to 1? Now, the important word there was the somehow. That's what that's the juicy part. That has all the information in it.
If you look at my calculations, you can tell the
Yeah, but give me a hint.
yeah,
It's not like a movie trailer. Like, you don't have to keep me hanging. Like, give me a hint.
Could you
Where is it?
6.
6, okay. Okay, you've got the cubic. You differentiate it. You made it equal to 0. Oh, I see. You used two variables, like the length and the width. And the equation at the end had the two variables in it still. You were able to simplify that into a ratio of 6 to 1 then. Okay. It's interesting. That works. Speaking of which, where's Jerry actually? Oh, there you are. You're so quiet today. I didn't see you there. Are you okay? Yeah. Okay. Listen. 7 and 8 you should do. Number 9 you don't have to do, but it's good to do it, but it's not really something I expect on the exam necessarily. I think what I'll probably do with the business students, when I do these with the business students, I will start at question 9 and work backwards. That way, if you looked at the start of their video, which I upload tomorrow, then it will have 9, 8 and 7 at the beginning, if you want to see how they're done. Okay? Alright, we're finished there, so